Stoichiometry calculations with mass. Sometimes our stoichiometry problems are a little trickier. You may be given the mass of a reactant and be asked to find the mass of the product. The coefficients from the balanced equation refer to moles, not mass, so your calculations will need an extra step to convert between mass and moles. Remember, you can look on the periodic table to find the molar mass of any element or add them up to find the molar mass of a compound. This tells you the number of grams in 1 mole of the substance, so you can convert between grams and moles. For example, water. 2 hydrogens is 2 times 1.01 atomic mass units. Oxygen, you just have one of them, and that's 16 AMU. So the mass of 1 water molecule is 18.02 AMU. The molar mass, or the mass of 1 mole of water, is 18.02 grams per mole. Example. How many grams of hydrogen gas would need to react with 3.4 moles of oxygen gas? We'll work with ratios like the last problems. So start with your given, 3.4 moles of oxygen. We can't convert directly from moles of oxygen to grams of hydrogen. We need to convert to moles of hydrogen first. So we have 3.4 moles of oxygen, and there are 2 moles of hydrogen for every 1 mole of oxygen. We're using the molar ratios from the balanced equation to convert moles of oxygen to moles of hydrogen. So here we are from the last page, and moles of oxygen cancels out, and one is in the numerator, one's in the denominator, so they cancel out. Now we will need to convert from moles of hydrogen to grams of hydrogen. So what do we have here? How many moles of hydrogen do we have? 2 times 3.4, so that's going to be 6.8. Using the periodic table, we see that hydrogen has a molar mass of 2.01 grams per mole. Now, hydrogen has a molar mass of 1.01, but since we're dealing with H2, the diatomic gas, multiply it by 2. So we're going to add this ratio to our calculation, and it looks like I got a step ahead of over there, but that's okay. So we have 2.01 grams of H2 for every 1 mole of H2. So now we take what we had on the previous slide, and we add the 2.01 grams of hydrogen for 1 mole of hydrogen. Now, make sure that the quantity you want, which are grams, is in the numerator, and that all your units agree and cancel, then finish the calculation. So we have moles of oxygen going out, we have moles of hydrogen going out, and we're left with grams of hydrogen, which is what we wanted. So that's 3.4 times 2 times 2.01 grams of hydrogen, and we get 13.7 grams of H2. Now we'd like to find the moles of ammonia produced by the reaction of 5.4 grams of nitrogen gas, that's N2, with an excess of nitrogen. We begin with the given. We have 5 grams of N2. We can't convert directly from grams of N2 to moles of ammonia. We need to convert the grams of N2 to moles of N2 first. We're going to need the molar mass of N2. Using the periodic table, we see that N2 has a molar mass of 28.02 grams per mole. N has a molar mass of 14.01, so there's 2 of them. Multiply by 2, and we get the 28.02. So we want to cancel out the grams of N2, so we're going to put the grams of N2, 28.01 grams of N2, which equals 1 mole of N2, and the 28 goes in the denominator here. And we're multiplying that by 4 grams of N2. Grams of N2 cancel out, and now we can convert moles of N2 to moles of ammonia using the molar ratios, and we'll do that on the next slide. So here we go, now we're ready to cancel. We put in our 2 moles of ammonia for every mole of N2 to the end here, and what are we canceling? Okay, we can go right down to here, it's the same thing, that's where we start canceling. We've got the grams of nitrogen, N2 cancel out here. The moles of N2 cancel out with the moles of N2 here. That's the ratio we just added. And looks like we're left with moles of ammonia in the numerator, which is good. And then the numbers, 5.4 times 1 over 28.02 times our 2 moles of ammonia, and we get 0.385 moles of ammonia.